Hey everyone, welcome back to the Naughty Samurai channel. In this video, we are going to explore the second method of the feature scaling technique, which goes by the name normalization. In the last video, we explored what feature scaling is and why do we use it, and also got into the applications of standardization, which is the most common sought out method for feature scaling. So if you want to take a look, check out the episode 9 of this series. So what is normalization? Before getting into it, let's first understand when do we use it. It covers the same base concept that standardization follows. For example, if we have two features in our dataset and one of the feature has very large values and the other feature has tiny values, so by default, the model ends up paying way more attention to the feature in which the values are bigger. Tiny valued feature ends up getting ignored. And that's where normalization comes in. Normalization simply means rescaling your data so that everything is on the same playing field. The most common way is called the min-max normalization method. This scales all the values between 0 and 1. So whether it's a bigger or a smaller number, the numbers now fit in the same range. As we understood the concept, let's get into its application now. As seen in the previous videos, we will begin by simply importing all the necessary libraries that are needed. After importing all of them, we will download the dataset directly from KaggleHub. These are all the important libraries that are needed. After that, we will fetch our file out and then print the last 10 rows of our dataset. Now what we want to do is, we want to understand the shape of our dataset. So for that, we will write data.shape command, we will run it, and it tells us that in total there are 614 rows and 13 columns in our dataset. Now, as seen in the previous video where I talked about the concept of standardization, I actually suggest you to go watch that video to understand the concept of feature scaling in depth. There, I also explain what feature scaling is and why do we use it. So in that video, we apply the concept of standardization in one specific column. Normalization is also another method of feature scaling, so it actually goes in the same exact manner. Here too, we will have to select a column to work with. In the last video, we worked with this applicant income column, so to keep things easy, I would apply the concept of normalization in this column again. Alright, so first what we need to do is we have to see if there are any null values present in this column. So we will write data.isNull.sum. We will run it. And it tells us that how many null values are present in each of the columns. So you can see gender column has 30 null values, merit has 3. And the column that you want to work with, the applicant income column, has 0 null values. You might have a question that what if there are any null values present in our dataset? How to deal with them? For that, I kind of explain you the concept of dropping the null values or replacing the null values with some other values in the very last video. So if you want to take a look and understand how to deal with the null values, you can just go watch the episode 9 of the series where I talk about the standardization and I also explore what to do if there are any null values present. I won't be showing the same exact thing here. So I would continue without dropping or dealing with the null values because we have 0 null values present in total. As I told you previously that after applying the concept of normalization, all the values will be squeezed down between 0 and 1. So before doing that, let's first take a look at the distribution plot diagram for this applicant income column. We will need the cbound library for that, so we will write sns.displot, and within it will be the name of the column, which is the applicant income column. And now we will write plt.show. Okay, let's run it. So here is our diagram for the applicant income column. You can see that most of the values are between 0 and 20,000, and even some values are stretched up to 40,000, 60,000 and even 80,000 in some cases. Alright, now let's import the min-max scalar library. Now we will apply the concept of normalization. So from sklearn.preprocessing, we will import min-max scalar. Now we will create an object of this class. Min-max scalar is the class name here. So we can name the object as So min-max scalar. And now let's fit our dataset. So what the fit method does is that it actually processes the dataset before applying the concept of normalization. So before applying the formula, it actually learns about the dataset and processes it down. So we will write fit. Within it will be data, and we will use double parentheses here, and there will go the name of the column, which is the applicant income column. Let's run it. Alright, so we have successfully fit the data down. So the processing is done. Now what we want to do is we have to shift the values, and we will do that using the transform method. So let's write mm.transform, and we will copy this thing from here and paste it right here. Let's run it. Now you can see that all the values have been squeezed down between the values of 0 and 1. All of those previous values have been changed now. So you can now see, you can understand, I hope you understand the difference between fit method and the transform method. What fit method does is that it actually learns about the data set before applying, and after it is done learning, it finally applies using the transform method. And when you apply it, you can see that all the values are now squeezed down and changes as according to the formula. Alright, we are done with it. Now what we want to do is we want to concatenate these values into our data set. So for doing that, we will create a new column name. Let's name the column as applicant income new. And now we will copy this line over here, which is the transform method. Okay, let's copy it and paste it over here. And now let's print the rows and columns of our data set. Now you can see that if you slide here on the right, you can see that a new column has been created with the name applicant income new. Now you can see the clear difference between the previous column and the new column. The previous column had values which were kind of quite dispersed, but the new column have all the values squeezed down between 0 and 1. So this is what we wanted. So you can see that we have successfully applied the concept of normalization. The very last thing what we want to do is we applied the distribution plot diagram, and we saw how our data looked before. So now let's take a look at the after diagram. I won't be writing the code down because I feel too lazy to do so, but I strongly suggest you to write it down and not be lazy like me. So what we want to do is we want to plot a distribution plot diagram for the before and after applicant income column. So let's run it. Now we can see the clear distinction between the previous column and the new column. So previously you can see most of the values were scattered between 0 and 80,000. Most of the values even though were between 0 and 20,000, but some values were stretched up until 80,000 and so. But after applying the formula of normalization, you can see most of the values are now between the range of 0 and 0.2, and the maximum those values were stretched up to was 1. No values were greater than the value of 1 or less than 0. So this works well with the machine learning model. If you fed this data to the machine learning model won't be able to accurately process it, and it would make predictions which should be wrong or very far-fetched. But in this case, as most of the values are between 0 and 1, your predictions of your machine learning model would be more accurate and efficient. This is it for today. We are done with the second method of feature scaling as well. I really hope you understood the concept, and if you did, please hit the like button and subscribe the channel because your support means the world to me. Until then, keep your mind sharp, your code clean, and stay sane. The Naughty Samurai signing off.